Environmental Professionals Network. We're so glad that you could join us this morning. Also, I want to welcome everyone joining us via our EPN YouTube live stream. This allows us to have GIS practitioners from across Ohio, including ODNR, Ohio EPA, and soil and water conservation districts from across Ohio. Live streaming also allows us to connect with GIS students and faculty from universities across Ohio, including Ohio University and Case Western Reserve University, so thank you for joining us. And I know for myself, I was very excited to learn that there was a GIS topic for EPN this month because, you know, like a lot of GIS professionals, I actually don't come from a GIS background. My background actually started in biology, and it's really common to hear in our industry people coming from other places. I've had colleagues in things like, you know, anthropology, archaeology, geology, computer science, mathematics, just all sorts, but we all came together because we have a love of GIS. And I think that's part of the reason that it's common to hear amongst GIS professionals just how collaborative of a community that we are. And so I hope that we can really continue to collaborate with one another, especially when it comes to GIS data and any sort of projects that we have going on, helping one another at the local level as much as possible. Especially considering some of the trends we're seeing at the moment with the federal level. So, on the topic of collaboration, let's see. Like I said, my name is Jessica St-Pierre. You're welcome to reach out to me anytime. If you want a little more background about what I do at the university libraries, I like to say that I do all things outreach and education when it comes to GIS here on campus. So this comes in the form of things like consultations with researchers and students. I do classroom visits, I create online content, and I also help organize events, which is my ulterior motive of being here today. We are less than a week away from GIS Day, next Wednesday, November 19th. I'm sure you already had that on your calendars, but it will be 10 a.m. to 3. You can show up and leave whenever you would like, just whatever works with your schedule. I have a QR code here if you would like to register for the event. It's a free in-person event over at the 18th Avenue Library. Let's see. So there are brochures with information about all the speakers. For in-person guests, there's a QR code on the table. We also have some paper copies of the program that we encourage you to share at your tables. For the live streamers, click the link that Molly Bean has posted in the chat. And I would also like to take this moment to thank our sponsors who help provide free registration for students, plus supported the costs of live streaming services. So thank you to the Sustainability Institute at Ohio State, the OSU Facilities Operations and Development, the Ohio Division of Wildlife, the Ohio EPA, Delco Water Company, the Water Management Association of Ohio, and special thanks to NG North America and the Ohio State Energy Partners, who are strong supporters of innovation and sustainability. So please join me in thanking our sponsors. All right, so now let's get started with our program. A quick note, we're also glad to be joined by the ENR 3700 course, Introduction to Spatial Information for Environment and Natural Resources. Those students who are here today as part of the class, thanks for being here. Again, speaker bios are in the brochure, and now I would like to pass the microphone to our student opening speaker for today, Julia Reed. She is an SENR senior studying Environment, Economy, Development, and Sustainability, or EEDS, with a minor in Geographic Information Systems. She's here to represent the student voice for today, so please join me in welcoming Julia.
Good morning, everyone. It's great to see you all here. My name is Julia Reed, and I'm a senior here at The Ohio State University studying Environment, Economy, Development, and Sustainability with minors in Geographic Information Systems and City and Regional Planning. I'm excited to have the opportunity to introduce this morning's program on emerging GIS applications for community and environmental health and share with you how I've been able to utilize GIS as both a powerful and versatile tool throughout my academic journey and in my professional internships. When I first started my freshman year here at The Ohio State University, I knew that I wanted to pursue a career in sustainability to learn how to make a lasting impact on the communities and ecosystems that I would one day serve. However, I was unsure about which specific skills or certifications would provide the strongest foundation for becoming a well-rounded environmental professional. My introduction to GIS actually came from my mom, a hydrologist at the National Weather Service. She strongly encouraged me to take a GIS course to gain a foundational understanding of its applications and heavily emphasized the extensive value of GIS as a tool that extends well beyond meteorology. Enrolling in my first GIS course, which was a 5,000 level course, alongside students who were in more technical fields like computer science, geography, or even graduate level students was definitely a little intimidating. However, I was eager to develop a more practical and applied skill that would complement my passion for sustainability. Learning how to use ArcGIS Pro for the first time definitely came with its share of challenges. Initially, navigating through the software and trying to grasp more spatial concepts like coordinate systems and projections definitely felt a little overwhelming. However, after many conversations with my professor, I actually grew to enjoy the detail-oriented nature of the software. I came to recognize its value not only for spatial analysis and cartography, but also for its ability to display complex information in a clear and accessible manner to diverse audiences. GIS is an incredibly powerful tool for presenting information to individuals who may not be GIS experts themselves. When I began seeking professional opportunities at the end of my sophomore year, I quickly realized how valuable my decision to pursue GIS had been. Developing a foundational understanding of this software provided me with a technical backbone to my major and equipped me with a marketable skill that is widely recognized across the industry. This skill ultimately led to my first internship in stormwater compliance at the Montgomery County Engineer. In this role, I supported the county's efforts to meet its requirements of its municipal separate storm sewer system, or MS4 permit, by completing dry weather inspections and completing a geographic information system of the county's stormwater infrastructure. This was really my first opportunity to apply the GIS skills that I learned in the classroom to a meaningful real-world project that allowed me to directly contribute to preserving water quality and supporting the health of local ecosystems. I've been able to continue applying my GIS skills in the role that I currently hold as an environmental intern at Environmental Design and Research, which is a consulting firm that specializes in renewable permitting across the Midwest. In this role, I've contributed to projects by mapping environmentally sensitive areas surrounding proposed development sites, analyzing vegetated areas that are designated for clearing during construction, and ensuring that every turbine and solar module maintains an appropriate setback distance from nearby residences and environmental assets. To conclude, I found that GIS is a technology that continually pushes me beyond my comfort zone, while allowing me to engage in fields that extend far beyond environmental sustainability. For many of us students here today, including myself, we are just beginning our own GIS journeys. So on behalf of the students here from Ohio State, Case Western, Ohio Wesleyan, Ohio University, and elsewhere, I want to encourage the environmental professionals and students in the room alike to make connections with one another and start conversations. What inspired your interest in GIS and cartography? What GIS work have you completed that you're most proud of? I think you're going to hear similar GIS origin stories from many of our speakers today, including our first speaker, Bryan O'Reilly. He's a data scientist and GIS analyst at Burgess Niple. Let's welcome Bryan.
Yeah, thank you so much for that introduction. So like you said, my name's Bryan O'Reilly, and I'm a data scientist at Burgess Niple. I started my foray into GIS here at Ohio State as a earth science major. I took one GIS class where I learned all of the right buttons to press in ArcMap. I took some of those skills over to when I was getting my master's at UW-Madison Environment and Natural Resources, using mixed methods research to help predict algal blooms on Lake Mendota, one of the major lakes in Madison. I used GIS there to help map sample points, but we also used GIS to coordinate with citizen scientists, getting that both qualitative and quantitative data input that helped us make those predictions. Afterwards, I Spent 3 years as a research analyst in emergency management, where GIS was a part of my daily job, making maps to help emergency managers make the best decisions on some of the worst days. Now, for the past 2.5, 3 years, I've been a data scientist at Burgess Niple, where we use these tool sets in projects including transportation, safety, and planning. And really what I want to talk about today is how GIS can bridge the gap between data and community voices. So in talking about that, we're really talking about combining qualitative and quantitative data to lead towards better, more trusted decisions. Data can drive those decisions, but numbers alone don't tell the full story. Without community narratives, data can lack context, it can lack buy-in, and so balancing the two really creates trust, equity, and impact. In practice, this means pairing geospatial data sets like crash records or temperature grids with community feedback and stakeholder insight. When we are approaching any problems in our job, when we're starting a project, we tend to use a very simple framework. First, we want to start with defining our priorities. Answer the question, why is this project important? What are we trying to solve? And we want to make sure that whatever we're doing really reflects the values and the needs of the people who are going to be affected. Next, we want to quantify those priorities, bring in that hard data, bring in the geospatial data, open up ArcPro, open up QGIS, and start doing some of the analysis. And by doing that, we can build analytical models that allow us to rank options against each other and really set our priorities. And then once that model is built, once we're proud of it, once we know it can stand up to technical rigor, we then set our ego aside and make sure that the results really match on the ground realities. Using feedback from stakeholders, from local experts, and community perspectives, we can refine the model in a robust iterative process. So the first project that I'm going to talk about today, this was a roundabout study in Clark County, Ohio. And I think it really illustrates the importance of GIS and how powerful it can be to pull out insights. So our client was a local MPO, TCC. The goal here was to systematically go through every single intersection in the county, over 5,000, and try to narrow that down to a list of the top 50 that would be top candidates for improvements to roundabouts. And then through community engagement and stakeholder coordination, we were able to get that down to a list of top 14 intersections for further study and cost estimation. And a lot of GIS went into this process. From locating all of the intersections, we didn't just have that geospatial data, so we had to take our road network, dissolve it, use an intersect to put a point down where any two roads crossed, and then QA/QC that data, because you're going to get overpasses, you're going to get dead-end corners. But a very, very powerful way to tackle that massive amount of data. But public feedback was also incredibly important. So we collected over 500 survey responses from the community, giving them an opportunity to say, whether or not they support additional roundabouts, what kind of safety or traffic concerns that they see in their community. And we even asked them to put a point down on a map of where they're seeing those concerns. So here you can see where all of the responses were, telling us why an area is of concern, as well as a map showing the hard data. So one of the variables that we looked at was crash density and crash severity, which is the heat map that you see there. But when we layer those on top of each other, we can see both where the problems are occurring using that crash data, and then dig into some of the narrative that we got from the community to understand why those problems are occurring. And this process was mirrored throughout the entire project. And I think this map here really shows where the power of GIS can come in. So we started with a ton of variables. We looked at crashes, we looked at roadway speeds, we looked at volume, we even looked at where are there elderly populations that need to walk, where do people tend to walk, where are schools located, all to kind of come up with this idea of where do we want to improve our infrastructure for the community. On top of that, we were able to layer on where can't we build anything? Where would we have to knock down 4 houses? Where would we have to take out a railroad? All of these things that would make a project impossible, right? And all of this was done in GIS. And then finally layering on our public comments, making sure that it reflects what the public actually wants to see, and then ultimately getting to a prioritization ranking of all of these intersections that we can then go to the city with and give them our recommendations. So I know that while I do a lot of transportation work, a lot of the folks here are going to be a little bit more interested in community and environmental health. So I wanted to talk through some of some examples that I've seen, some that I've worked on, that I think really show just how cross-cutting this technology is. When I worked in emergency management, I worked out of DC. So I'm very familiar with this map to the point where I've argued that it shouldn't need a north arrow because everybody knows which way is north, at least if you work in the district. But here you're seeing another example of how we can layer data on top of each other to come up with recommendations. So the first map that you see is a extreme temperature range around the city. You can see how variable that is. On top of that is a map of NDVI, which is a remote sensing term for essentially foliage for tree cover. We all know that the more trees there are, the cooler it can become in the area, and you can actually see how that plays out. Where you see high foliage, you see lower temperatures. And then by bringing in a lot of equity factors like income, like minority populations, folks with disability, elderly populations, you can actually then understand, okay, if there is a heat wave, where do we need to focus our resources by looking at a heat sensitivity index? Where do we need to be planting more trees to help those populations? Really helping make those decisions. And then the other example that I want to talk about, this is from my master's research. This is a map of Lake Mendota. And what I really want to focus on here is not the statistical analysis that I did, but the hard work from all of the citizen scientists that we collaborated with. So we partnered with a local nonprofit called Clean Lakes Alliance. They were really good about getting out into the community, finding people who really cared about the health of our lakes. And so I was able to teach a class on how to take water samples, measure phycocyanin, which is very important in this research, and got a couple dozen folks who are now taking water samples for me over the course of a summer. And that really helps us understand, you know, how do algal blooms change spatially across the lake? Is it always the case where you have to close all of the beaches, or can you just close one or the other? And it also gave me a ton of data that I could then train predictive models on, so that, you know, in May we can know how bad is it going to be in July when we see the worst algal blooms. And this was really important because the result wasn't just better accuracy. It really built community ownership. So when residents see themselves reflected in the data, they become allies in both identifying and addressing environmental issues. I want to talk a little bit about some of the actual tools that I use in my work. Obviously, we use the standard GIS tools like ArcGIS and QGIS, but there's a lot of other data that goes into this. So for stakeholder engagement or community engagement, we have focus groups, workshops, and public surveys. If you're ever trying to get spatial data from a public survey, Survey 123 is an incredibly powerful tool. I also use Qualtrics quite a bit for more complex surveys, as well as using the natural language toolkit in Python that can really help you parse through 500 paragraphs of comments to pull out the important information. For data analysis and visualization, so I use R, I use TensorFlow and sklearn Python libraries for machine learning, as well as obviously ArcGIS and QGIS to layer on the data, do the geospatial analysis, and ultimately create visualizations. And then it's also important to have frameworks that, translate technical analysis into actionable investments. So having things like prioritization trees, being able to explain that to your stakeholders. And so as we think about GIS applications, it's very tempting to focus on the technology itself, the dashboards, the survey tools, the spatial models. But GIS is really just a toolbox. The real power comes from how we use it. From building robust processes that bring structure to complex problems, to listening to community voices, that the power really comes from applying that toolbox to the things that we care deeply about, whether that's transportation safety or environmental health or any other passion that you might have. And that's where the best work happens, when data, process, and passion align. Because at the end of the day, data tells us where, but people tell us why. Thank you.
Hey everybody, I'm Aaron Laver, sorry, I am a walker. I'm gonna try my best to stay in front of the mic here though. It's all just points, lines, and polygons. That is the phrase that I get to hear multiple times per week when on client meetings with my partner Mike Bowen. And if I'm feeling especially snarky that day, I'll correct him and say, no, it's more than that. But when it comes down to it, the thought remains the same, and the premise remains the same, of that there is a finite amount of way that you can display information on a map. You can boil any industry's information down to points, lines, and polygons. So clients, we use this line, and we use this phrase really anytime that a client approaches us and says, hey, we have this problem, and we have this information available. Do you think that we can solve it? And, it's kind of a tactic that I think Mike employs a lot of times, basically without admitting, hey, we've never seen anything like your problem, man. I think that the premise is a resounding, yes, we can help you because the concepts of mapping and cartography are pretty much ring true across any industry that you can really think of. The thing that's consistent is you need to have information, you need to have data. I'm a data guy. I like to think of GIS as a lens more than it is anything else. I don't even like to think of it as a software. Little dirty secret that us GIS folks have is that every bit of every layer that you're seeing on a map is literally just a fancy Excel sheet. There's one column in that table that is spatial. And so when you're thinking about things like customer transactions and things like that, you can think of a receipt number as a record of a purchase. You can think of a customer ID as the person who made the purchase. In a similar way, that column is the ID of where that took place or where that asset lives. And so it doesn't matter if your data is 2 columns or if your data is 7 columns or 154 columns, as you can see there. The spatial component really just comes down to that one column. So if you get really good at working with that one column, then it's going to take you pretty far. And like Bryan was saying, it really comes down to how, or the why behind it, and why are we looking at this information and what can we glean from it in the other columns that exist in this data set. And so we started working with Holmes County about a year ago, and they are, who's been to Holmes County before? Just a show of hands. So a lot of people, good. They have a unique circumstance in that they need to keep up with technology in general to keep up with compliance and state standards and regulations and things like that. But they are home to one of the largest Amish populations in the entire world. So they also have to keep their methods traditional to the sense of being applicable to the people that live within the county. There was a study that came out before we started working with them that identified the 6 sampling locations and that failed E. coli testing. And that is from a recreational standpoint, that's a big problem. And so they kind of independently, departments sought to fix that problem, looking at paper records, like the health department, if you look at their septic systems permitting, their system was literally a file cabinet in the corner that they had to go and pull from every time they needed to pull inspection or pull up a record. And so they approached us and said, hey, can you do something about this? We think that it's time to go digital, at least in some way, shape, or form. And what I got to give Eric Parker, he's the GIS coordinator over there, a lot of credit. All of these departments trying to tackle the same problem independently of the other department, they were coming to him saying, I think that GIS is the answer for me, but I don't know if, I think that GIS is the answer for me, but I don't know how to go about implementing it. And Eric hit a point where he just said, guys, you're all coming to me with ultimately the same issues. We're trying to tackle the same thing here. So we got everybody in a room and used GIS to connect everybody and really just kind of start to coordinate efforts along the way to try to fix this problem, yes, but also just move the county forward. So they formed what's called this Holmes County Water Quality Initiative, and that's when they reached out to us to help them to fix the problem. Right here you can see, just by looking at the map here, I'm trying to walk again, just by looking at the map, you can see where the sampling locations are. You gain a little bit of clarity just by looking at where they are. So the stream is flowing south, and you can see where the larger values are concentrated there. And then when you add farms to the mix, you automatically know where you might start to see the non-point sources coming in. And it's AI generated because, fun fact, you can't actually display farm information. It's illegal to do so in terms of what the Soil and Water Conservation District has. So I decided to let AI help me there. But it's just use your imagination. This is the septic systems. And for those of you who aren't aware, a septic system, just for a private residential home, has a life expectancy of about 30 years, and then they start to see increased risk of failure. By digitizing their infrastructure or digitizing their permitting system, what they were able to do is actually take a look back and say, okay, this is our problem watershed. Where are the systems that are older than 30 years? And there's a lot of them. And now they know where to start, at least going and inspecting and making sure that everything is working with those systems. And same thing with the sanitary sewer. We put them on a map. We start to be able to see all of these things together and know where to look. And the cool thing about this particular map is that you can see where the sanitary sewer is, but if you go back and forth between the two, you can also see where sanitary sewer makes sense. So you can see the clusters, so the absence of the sanitary sewer tells you something here too. It basically, seeing these aging systems on the map lets you kind of figure out where there are big clusters of aging systems where you might be a prime opportunity for a grant or something like that to make sweeping change in a particular area. It's a kind of a grainy photo, but adding another layer outside of what's collected by the agencies, you can add in publicly available information in the form of DEM data and the stream network and figure out where the non-point sources or where the septic systems are that are aging or potentially problematic, and you can actually figure out right where they exist in such a way that they're going to go right into the stream if they fail. So all of these things are made possible through this geospatial lens. And I guess just another example. How am I doing on time? Good? Okay. Another example over the years, so I was approached by Black Swamp Conservancy about 4 years ago. I think Rob's in the audience here somewhere. But they have a big footprint, historically about 14 counties that they serve, and they wanted to prioritize wetland restoration with this new H2 Ohio program that we had in Ohio to figure out where they should prioritize restoration activity. And said, hey, I think that GIS is a solution here. They have some folks who had used GIS here and there, and so they asked for some help in building out a model. Fast forward about a year later, and we have a working model that takes 650,000 parcels across the 14 counties, and it scores them one next to the other on a 0 to 100 scale of what is going to be what has the most potential to implement a successful wetland. And that success criteria is going to change, but the parameters associated with that parcel are relatively consistent. Fast forward 4 more years, we're now on version 3 of it. We've expanded to 24 counties. Instead of just Black Swamp using the tool, we have 19 organizations who are all working together for water quality in the region who are using this tool. 1 million parcels, and instead of one 0 to 100 score, we have 3 of them because priorities change all the time, whether you're looking for habitat, whether you're looking for water quality benefits, or any other kind of ecosystem benefit. Data enables you to kind of adapt with these circumstances and filter out what you need and identify these parcels and score them based on your priorities. So I guess with that kind of being said, everything exists somewhere. There's this overused statistic out there, which I'm convinced isn't really a statistic at all, it's just marketing, but that 90% of the information in the world is spatial or has a spatial component to it. You know, I think that nobody's really tried to discredit that because it makes sense, right? If you were to take a data set of Brian's cell phone data and my cell phone data, and you were to take all of our steps as a row in that data set, you'd be able to tell that at some point Brian and I probably met along the way. I've known Brian for, about a year-ish now through Ohio GIS Conference and things like that. You might even be able to deduce that we're friends or colleagues. So that is, in a world where we have an abundance of data, it really just becomes a question of what's important to us and how can we use it to meet our goals. So with that being said, I think that that's pretty much all I have. I will go ahead and pass it on to Ellie, who's with Black Swamp.
Good morning. Like Erin said, my name is Ellie Schiappa. I'm with Black Swamp Conservancy. I'm a conservation associate with the Conservancy, and we'll talk a little bit more about what that means and what I do. But we are a nonprofit land trust located in Northwest Ohio. And as a nonprofit land trust, we work to protect and conserve land across our service area, across the region in perpetuity. So we work with a large range of landowners and types of habitat. That includes agricultural landowners, so we do a lot of agricultural preservation. We also work with landowners that own and manage natural habitat, so some coastal marshes along Lake Erie, other natural land cover, wooded areas, wetlands, and then we also own some of that land as well. So we also own and manage some natural habitat across the region. So this is our service area. You kind of saw it in the PERM model that Erin showed on the screen just a bit ago. And we're going to talk a little bit more about how we actually utilize the model that Erin created for us to enact actual conservation projects on the ground. But first, I need to brag a little about our accomplishments before we get to how we use the model. So we currently protect just over 22,000 acres across that service area. It's a large service area. across, almost 14 counties. And we protect land in two different ways. So the first, we own and manage our own nature preserves. So we currently own and manage just over 1,800 acres. That's about 15 nature preserves. Most of these preserves are closed to the public. We manage them for wildlife and for habitat preservation, but we do have a few that are open that have some active trails that the community can utilize and get out into nature of Northwest Ohio. Some of those are also remnant Great Black Swamp. So this region is the historic Great Black Swamp that was decades ago drained in to utilize for the fertile soils for agriculture. So we have prime soils here in Northwest Ohio for farming. So we have a lot of acreage of farms. Oh, sorry, I didn't mean to. So the other way that we protect land is through conservation easements. So this is where I work. I work with all of our conservation easements. Our conservation easements are perpetual land agreements that we put in place with often private landowners. We currently hold about 150 easements. That's the majority of our acreage, so just over 20,000 acres in easement. And again, these easements range from all different types of habitat and all different types of landowners. We work with private landowners. We also work with some public entities. So we do work with some park districts. We have one partnership we have with a local school that we were able to work with them to create a living laboratory that the school can utilize for their different classes. So we have a lot of different kind of models that we follow to accomplish preservation, and a lot of those projects were done using the PERM project. But we use geospatial tools in a wide range at the Conservancy. So we have a lot of things going on. We do education, we do easement monitoring, we do land management, and we use a wide variety of geospatial tools to be successful in conservation. So we use Esri products, we're on the computer making maps. We also use a lot of field mapping tools, so we're out in the field using tools on our phones or with a GPS unit. So I'm going to go through some of those examples of how we use this variety of geospatial tools. Geospatial world is humongous. So one of the ways that we use it is to create our baseline documentation reports. So these reports are essentially a snapshot of a property at the time that we protect it in easement. And so we go to the property, we do a lot of background research on the computer, so I'm using some of our geospatial tools and models that are out there and accessible to us, but then we're also on the ground with the landowner, kind of talking about land use, land cover, and we create a lot of different maps to represent the property in different ways, and that would include maybe land use, land cover, we create soil maps, and we capture different parts of the property in different ways, so we have a really inclusive documentation that we can go back to for years to come to make sure that the property stays as it is or is improved. We also use that for property management. So as I said, we manage and own about 15 of our own preserves. So our land management team uses field mapping and other mapping tools for the variety of management that they do on the property. So this might include invasive species management mapping. So this is a map that our land steward created for one of our preserves in Sandusky or in Seneca County, and it is mapping. It might be kind of hard to see, but it's mapping the different invasive species of areas of concern that she saw on the property. So she was able to highlight them, color code them. So then in the next season, they're able to target those areas that she was able to map. So she was able to go out into the field, map those in the field, and then translate it into a map for her and her field crew to be able to easily decipher. We also use it, of course, to map our trails. So this is one of our preserves. This is our largest preserve in Paulding County, our Forest Woods Nature Preserve. And again, we're able to be out in the field, map our trails, and then use that to communicate that to partners or to other staff that might be visiting the property. I use it almost every day with my easement monitoring. So as the easement monitoring stewardship person, I'm out in the field with landowners. I'm visiting all of our easements at least once a year. And I use field mapping and other types of geospatial tools to communicate issues that we might see. So this is an example of a map that I was able to create after being in the field to communicate to the landowner something we might need to resolve together. And then, of course, we use models to identify priority land protection projects, such as the PERM, that we'll talk about a little bit, as Aaron mentioned. So we use this model in a few different ways. The first is identifying priority projects. So we really, when we are presented with a project, we ask ourselves, what ecological value does this hold? And then, of course, is there valuable restoration potential? We don't do restoration on all of our projects, but we do them on a lot of our projects, and so that's a big question that we often ask ourselves. So one way that we have these projects come up is landowner inquiry. A landowner will come to us and say, hey, I want to protect my property. What are my options? And we're able to use a variety of geospatial tools, including the PERM, to kind of analyze, what ecological value does this property might have, and is this something we want to take on? We're a small organization. We have a staff of 7, so we have low capacity, low resources, and so having these tools allows us to really ensure that the projects that we're taking on are of high value, both for current conservation and then for the future. We protect these lands in perpetuity, so we need to ensure that those values that we're protecting have those, we're able to meet the management that's needed. So this is an example of a preserve that we just purchased. It went up, it was available, and kind of what we were seeing on the PERM end when we ran it through PERM. This is one of our newest preserves that we just purchased and will be restoring in the next year or so. We also work with partners to collaborate using PERM. So we're able to utilize the PERM to kind of help our partners accomplish projects as well. This new version of PERM, as Aaron mentioned, has really expanded. So we're working with tons of people using PERM to accomplish restoration across the state, not just in Northwest Ohio. And then lastly, we use it to target priority projects. So this is a case study, a current restoration project that we're doing in Ottawa County. So at the beginning of the PERM process, we decided to filter through all of the parcels that had a score between 98 and 100. So this meant the restoration potential was perfect. This is exactly what we're looking for. And once we went through that filter, we were able to grab a handful of properties that looked promising, and this one popped up. So this is our Schlevert Farm and Floodplain. You can see it scored in 100, so that is a perfect feasibility score that we were looking for. And we had an existing relationship with this landowner, so kind of made the communication a little bit easier, but we were able to go to the landowner and say, hey, you have a really cool property and we have this cool idea. So this is the property. It is an agricultural property, but you can see it's right on the Toussaint Creek, so there's that natural area right in between the agricultural property. So we went to the landowner and we kind of presented this concept of, hey, we have this cool restoration idea, and this is what it could look like. And he was really excited about it, and we were able to engage him. We now hold a conservation easement on this property. He is still the landowner. But the construction for this restoration is actually starting this month. So the idea is that natural buffer is going to be restored back to wetland, while he still retains rights to farm the agricultural area, and it really works as a great case study of showing the runoff from the agricultural fields filtering through the wetlands to hopefully improve water quality that will ultimately end up in the Western Lake Erie Basin. So that was kind of a quick overview of how we use the models, and of course we'll have time to talk a little bit more about how we use these tools, but I'm going to pass it on to Chelsea to talk about their work at the Stream and Wetlands Foundation.
Okay, good morning. I'm really happy to be here, especially to talk about GIS. I love GIS. I am not a GIS professional. There's very strict requirements to call yourself a GIS professional that you have to meet. But Aaron kind of reached out and said, looking for power users. So I would consider myself of that in my work doing ecological restoration. So I was asked to share a little bit about my kind of education and career path, and then I'll also share some insight into how I use GIS in the work that I do currently. So I graduated with an undergrad in environmental science, and at that point, this is a relatively young field, environmental careers, and GIS is a relatively young technology as well. And so when I graduated with my undergrad, it had kind of just transitioned from agronomy, soil science to environmental science. And so that was the heavy focus, was kind of more soils based, and I didn't touch GIS. I had no exposure to it. And so I worked at an environmental testing lab for a few years, actually like really close to where we are here in downtown Columbus. And then I went back to graduate school, and that's where I kind of had some exposure to using GIS. And I think basically just a professor was like, hey, you should check this out. That was the extent of it. And so I took a GIS class in the geography department, and it was good, but I think anybody that uses GIS, I feel like we were talking beforehand, is a pretty common experience where it's just like, here's a list of things to click buttons and kind of learn how to use the tools. But it helped me kind of get a perspective of how you can use GIS in so many different ways. And we've already, seen a lot of those with the presentations that came before me. So it kind of piqued an interest, but I certainly did not come away with a super strong understanding. And then I took another GIS class that was in my department, Plant and Wildlife Sciences, and that was more relevant, more focused on, kind of like wildlife and these types of things. But again, same sort of thing. I came out of it being like, all right, I did an exercise on learning how to buffer, and I did an exercise on learning how to use the clip tool, but I didn't come out of it feeling like I totally was like confident to say, yes, I understand this. And so for the students here, like I recommend absolutely take GIS classes. It's really powerful and it's very marketable, but don't feel bad if you come out of it feeling like a little bit of imposter syndrome. Like I learned a lot of things, but I don't actually know anything. I think hopefully that's a common experience. Maybe it was just me. But anyway, so when I was interviewing for the job that I have now, that was a big part of the interview was my GIS experience. And so even though it was just university classes, the Stream Wetlands Foundation is a small organization, even smaller at that point. And so there was one guy who was using GIS, and he was very interested in having somebody else that could help with that workload. And so, a good part of my interview was, tell me about your GIS experience. And I was like, I learned how to, do these things, whatever. But good enough that they took a chance on me and I got the job. And so once I started using it in a professional capacity and kind of had a mentor go through sort of start to finish, this is how we use it, this is how we organize our file structures, this is how we save things in the geodatabase, kind of going through all of that and using it actually in a real setting, connected a lot of dots, filled in a lot of gaps, and I was able to see like this is so useful, so critical, and I don't even scratch the surface of the capabilities that are in there. I think, Brian and Aaron were talking about like this kind of heavy geoprocessing they do. I use it more for like glorified map making, but still incredibly powerful with the work that I do. So we do, at Stream Wetlands Foundation, we do wetland and stream habitat restoration. And so I use GIS probably every day in a lot of different ways, but kind of starting the process of identifying a property of where we might want to do restoration work. I guess kind of similar to what Ellie was talking about, but a little different. So I will kind of start by opening up a new map, ArcGIS Pro, and bring in all the information that I can find on sort of a desktop analysis. So I bring in soils layers and parcel data, hydrology layers, watershed information. If I can find information about existing easements or utilities on the site, I'll bring in LiDAR data and build contours and build slopes to see where's the water moving, look at the soils. So all of these things to get as much information as I can before investing time and energy into actually going out. So once we do that, then of course you need to ground truth. You bring in the National Wetlands Inventory layer. Anyone that uses that knows it's like notoriously inaccurate, so you actually need to go out and you need to ground truth all of the data that you've kind of pulled in to look at a site. And so, we'll start with kind of like what Ellie said, baseline mapping of to go out and do a delineation, and you collect that data with your GPS and you bring it in and you put it into a map, and then you might map the stream corridor if there is one. And then, if we say, okay, this site's suitable, Then I start putting together exhibits and figures in support of a restoration plan. So here's just kind of an example of one. This is a project we did west of Columbus, so pretty close to where we are now in Prairie Township. And you can see on this map there's a utility easement. You can see the existing stream, and then you can see the restoration plan of the new stream. So 2 new streams that we did full channel restoration. We proposed a trail system so that it can eventually be used by the park district, be open to the public, and then different berms to kind of help connect contours where maybe the site has been flattened through farming, and so we're trying to kind of reconnect contours, hold the water, keep it on site so that we can do successful wetland restoration. And so a lot of the design work, especially the stream design, is done in CAD. So, different tools, right? We talked about that. Different tools are better for different things. But the nice thing is that Arc Pro now has the capability that I can reference CAD into it. And so, my coworker who's a professional engineer will do the stream design. He'll do the earthwork calculations, and then he gives that information to me. I pull it into GIS, and then I make a nice looking map because GIS has better capabilities for layouts and making things look attractive. And that is important when you're trying to tell a story and you're trying to convey information regardless of what it is, right? And so, here's this plan that we put together for our habitat, and then we go through and get all our approvals, federal, state, local approvals, and then we build the project. So here's just a couple photos. This is kind of precondition. It was a farm field with some straightened ag ditches, doing the full stream construction, and then here's some drone shots during construction. And so this is about a 150-acre site. So another thing that we use GIS for is creating a seeding and planting plan. So 150 acres, you can't just go out with a bag of seed and start throwing it around. You need to have that sort of spaced out, so you're doing appropriate densities. Same thing with planting trees. And so, we use that to make those types of maps, and then we'll collect as-built data and again, compile that into other maps for, different information depending on who we're trying to convey that information to. And then once we've sort of, we're trying to mimic what nature has done over hundreds and thousands of years in like a 2-month construction period. So we build the site, and then we're trying to, give it a good start, a trajectory for success. And so, we seed with native seeds, we plant trees, and then the big thing is treating invasives. So we don't want the invasives to come in and get a foothold right at the beginning. And so, our teams will go out and they'll map invasives and share those to the spray crews. We set up vegetation monitoring plots, and all of that data, comes into our geodatabase for ourselves, and then also for when we're done with these projects, and if we're going to donate it to the park district. Here is a whole geodatabase of information that you now know the history of what we have done at this site, and you can use that for your ongoing maintenance. And so it's incredibly useful, it's incredibly powerful, and as a nonprofit, we get really good licensing pricing. And so I always say it's like the best bang for the buck that we have, because we use this so much in so many different ways and use it to make, real financial decisions as well. And so it's definitely something that is really worthwhile. And I will also say, I think probably almost all careers in the environmental field, you're going to use this in some capacity. So whether it's just having a GPS unit in the field collecting data, or whether you're doing some of this like really intensive geoprocessing, like having experience and at least a little bit of exposure to spatial data, and whether it's ArcGIS or QGIS or others, it's powerful and it's marketable. So for you students out there, and then just another super quick example, a little bit different. I worked with the Arc of Appalachia, who's a land conservation group, to kind of jointly apply for a Clean Ohio grant. So we were approached about this property. It's about 870 acres in Gallia County, and it was privately owned. And the gentleman was getting older and was kind of ready to sell, and we really wanted to be able to acquire all of it so it didn't get split off into different parcels, and it's bounded on 3 sides by the Wayne National Forest, and so from like an ecological perspective, like could be, you know, very important, but because it's been privately held, like not a lot of survey or like research has been done on the site. And so we just needed a small part for our stream restoration project, so we worked with Arc of Appalachia to apply for this grant so that we could get the entire site and protect it. So some of it is a requirement of that grant that they want lots of different documentation. So they want an aerial map, and they want some existing conditions maps. And so I put all those together. But then you're also trying to do things to strengthen your application, right? So show that it's valuable. So you want to show, are there rare habitats? Are there, endangered species? And it's 870 acres, so that's really hard to walk the whole site to actually collect that data. And so this map on your left, anyway, is a tree canopy map, and this one was kind of fun. So I created like a digital elevation model and digital surface model, and you subtract them, and then like magic, the trees pop out, and you can see them, and you can kind of sort it by tree height. And this gives you an idea like, all right, so the areas that are red and orange, those are the areas with the tallest trees. So in theory, those are less disturbed and maybe the nicer habitats, and that's where you can go focus your investigation and kind of narrow it down from the full 870 acres. So that one was kind of fun to make. And then, we had to we didn't actually walk every single stream channel, but map the stream channels based on topography and then, again, ground truthing to some extent. They wanted a soil erodibility layer, and then kind of an overview map. These are the existing houses on the property. These are caves that we found. This is where we're proposing to put in a trailhead. And so all of these things in support of like making this a very strong application. The map with the purple is kind of the areas where down in the valleys where they had run cattle and done farming, so those are areas that maybe would be really good for future restoration work. And we did actually find a few threatened and endangered species, but I didn't show these on the map, and that might be something we'll talk about in the panel again about like ethics of how you want to convey data and making sure you're doing it in a safe way that's not potentially damaging. And so we were successful. We got the grant, and so this is now the Mudsock Preserve that is owned by the Arc of Appalachia. So it was pretty cool, and it was exciting to be a part of that. And just as a kind of a plug for the students and professors here, so we are a nonprofit, and part of our mission is education and research. And so we have 5 scholarships that we do every year. It's $5,000 scholarships, and you just need to be at an Ohio school and majoring in something to do with biology, environmental science, engineering, anything that's sort of in the natural resources realm. And it's open for undergrads and graduate students. So that's that top QR code. It's opening December 1st. And then the bottom one is our Instagram, where our field team just likes to post pretty pictures of our sites and plants and animals. So feel free to check that out. And that's what I have, but thank you so much for your time and the opportunity to speak about this, and I'll talk to you all in a minute at the panel.
Okay, good morning, everyone. I am Harvey Miller, and I'll be handling the Q&A during this session this morning. I am a professor of geography here at Ohio State. I'm also director of the Center for Urban and Regional Analysis, or CURA to our friends. Just briefly, I'd like to tell you my origin story around GIS, because we heard a few origin stories this morning. I'm OG GIS. I've been around almost as long as GIS has been around, literally because the first GIS, fun factoid, was developed in Canada, the Canadian Geographic Information System, in the 1960s. Next time you see a Canadian, you can thank them for GIS. My experience is I was a sociology major with a minor in urban studies at Kent State University in the 1980s, intended to be an urban planner. And one day I was taking a class in economic geography, and a professor said to me, there's something big coming called Geographic Information Systems. It's going to change everything. And I immediately switched my major to geography, and 3 geography degrees later, here I am in front of you. So, like I said, I'm OG here. GIS is powerful, not just because of its ability to integrate diverse data, which is something we saw this morning, integrating diverse data based on geographic location, but something else we also saw this morning is that it's powerful because of its ability to foster systems thinking about difficult problems and to foster discussion and understanding using one of the most profound technologies in the history of humanity, which is the map. I think people should never apologize for using GIS just to make a map, because maps are profound. If you're making good, faithful maps with GIS, you may not be a powered GIS user, but you certainly are a powerful GIS user. So I just wanted to make a little comment on something I heard this morning, and I've heard in discussions surrounding this panel before we got together. My own research involves GIS involves sustainable mobility in cities, trying to understand the impacts of transportation on social, economic, environmental, and health outcomes. I work with geospatial moving objects data where those objects are people moving through cities. And we have a lot more of that data now than we ever had in the past history of urban science and transportation science. I'll just say something about CURA, and then we'll move on to the Q&A. CURA is one of the biggest GIS shops on campus. Our mission is research and outreach to foster more sustainable, resilient, and connected communities in Ohio and beyond using geospatial science and technologies. Check us out at cura.osu.edu. You could see some of the wonderful things we're doing with GIS in Columbus and beyond. So now we're going to have some Q&A. I'd like to invite the panelists up to this, like a beautiful park bench there to have seats, and we'll start the panel discussion. We'll have about 20 minutes of panel discussion, and then I'll ask some questions among the panelists, and then we will open it up for the audience. Okay, thank you all. So let's start. I have some cross-cutting questions. Maybe we'll jump in and have individual questions as well, but let's talk about accessibility first of all. What are some ways that GIS can be made more accessible to non-specialists, including community members and smaller organizations? Who'd like to jump in first?
Hello, can you hear me? Okay, cool. I'll go ahead and I guess tackle that question. The thing that I kind of see the most is, I guess there are 2 big barriers. One of them is the user interface of a GIS can be very daunting, knowing what buttons to push and things to find. And the other big barrier that I'm seeing is licensing. So Chelsea mentioned it, especially for small outfits, small private companies, or the licensing can be very, very prohibitive, and it can stifle progress. So you think about being a small contractor, for example. Maybe you are a utility contractors, you're building utility poles or something like that. You serve to gain a lot with GIS, but you can't necessarily access it because of the barrier to entry of cost. So I think that open source software not only becoming more accessible. I just saw a map the other day of open source QGIS versus ArcGIS Pro. ArcGIS Pro has been mentioned a lot today. 10 years ago, across the world, ArcGIS was king. Now, for a lot of different factors, one being cost, but I think more so community and even just the internet and the cloud, QGIS across, Esri's still the top in the United States, ArcGIS is still the top in the United States, but QGIS, for the majority of the world, is actually the preferred software more and more, not because it's better than ArcGIS, because it's more accessible. So I think that the software itself becoming easier to use, plus the, I guess, evangelism of open source technology that's available and also made easier through large language models. All of those can contribute to making it more accessible.
Yeah, I'll add on to that. For any students out there, heavily encourage you to learn about the open source tools that's going to serve you really well in your future career, especially QGIS. Look through the plugins. There's a lot of help online to learn that. Just with any other GIS software, once you learn where the buttons are, the sky's the limit. Another take on accessibility that I like to think about, and we think about a lot when we're making maps that are going to be for public consumption, is accessibility in terms of like ADA compliance. So making sure that you're choosing colors that everybody can understand what you're trying to say with your map. One lesson I learned very early is that you never want to show red versus green for people, because red is bad and no person is inherently bad. So that was something that you intuitively want to use red and green, but just being respectful of the community, making sure you use other colors.
Yeah, we were actually talking a little bit about this before the session started, but I think, licensing, we're a small nonprofit as well, and like Chelsea said, we get a pretty good deal on Esri licensing, which is wonderful, because without that, we wouldn't be able to probably afford the program as an organization, and we rely on it so much. I think so. I have a background in, my undergrad is in, I have a bachelor's in geography with a concentration in environmental studies and sustainability. And I was graduating right as ArcPro was being released. So I did all my classes. I got a full degree in geography in ArcMap. And then I hit the professional world, and they were all like, we're using ArcPro. And I was like, what? And so I think like a note to professors too, and that are teaching these, geospatial classes, and I felt very pigeonholed in the program that I used in my undergrad classes, which didn't serve me as well. And so, with these new emerging open source technologies and so many different types of tools, being able to use multiple of these platforms, because you never know what you're going to get into when you get into the professional world. And maybe your organization does just use QGIS, and admittedly, I don't have that much background in that, and it would be a big learning curve for me to have to kind of switch those platforms. And the difference between all of the platforms is tough, and they don't always talk great to each other either, which is also a big barrier.
I don't have a ton to add. I think open source, that was probably going to be the big one as far as like accessibility. The other thing is, I think one thing that is good about Esri, I know they're expensive, but they do offer different types of pricing. And I think I looked into this a little bit, like a local library could get licenses that they can then share out to community members. So if we're talking about that piece of the question, I think there is the ability for people to get access if they kind of push for it. I don't know, the Ohio State Library obviously has that, but even a local library could do that as well. But so I think there's possible, but people have to be aware of it and have to want it and make that request. And maybe there's then pressure with competition that Esri is then more open to lowering their prices. But yeah, I don't have a lot else to add other than that.
Okay, let's move on to a second cross-cutting question about geospatial ethics and equity. How do you think about equity when using spatial data in terms of representation, access, and outcomes? And also, more generally, how do you make sure that your GIS products ethically are faithful and represent the reality you're trying to display?
So I'll start because I have the microphone still. So I alluded a little bit, I guess, from the ethics standpoint when I was speaking. We have to be careful in sharing data. Are we protecting privacy and honestly protecting safety? So particularly in the environmental field, we talk about threatened and endangered species, and we have a project where we're doing some monitoring for eastern Massasauga rattlesnake, which is an endangered species in Ohio, and it's been made very clear, like, you do not share any information about location because of potential for poaching. And kind of the same thing with that Mudsock Preserve. You know, we did find some rare plants. Again, we're not publishing that. We're not making that available. And that's on the environmental species side, but also for like human beings, right? We need to be careful about sharing real-time data. Are we doing it in a safe way? And then I guess my thoughts on the ethics question, you know, maps are very easy to make look the way you want them to make, and they're very easy to be biased. And I think, you know, kind of, I'm not saying this is true, but the example that sometimes is out there is like the Mercator projection map, where it's, you know, it's showing very Eurocentric, and it's showing Greenland the size of the entire continent of Africa, where really Greenland's the size of one country in Africa. And so is that like fairly representing, you know, historically and currently, you know, underserved populations, right? And those types of kind of ethical questions. And we also love to talk about AI, and that's like the big exciting new thing, but also being ethical in the way that those models are being developed. I was at a conference where there were some companies talking about like, hey, we're using all this AI learning, and we're gonna do these like, add these capabilities to our software. And I kind of like asked the question, which probably annoyed them, but was like, what information or what data are you using for your models? Like, is that your client's data that you're collecting, and then you're using, do you have permission from your clients to use their project data for your learning models? And they kind of didn't really have an answer for me, but I know that that's something that has been going on with that, is using intellectual property to train these models. And so that's, you know, are we okay with that from an ethical point of view? So.
Right. Yeah, so we deal with a lot of the same, you know, protecting endangered species. We work with a lot of sensitive habitats in Northwest Ohio. We hold and own 2 preserves that are remnant Great Black Swamp, and so there's a lot of sensitive species within those habitats that, you know, we have to protect it and be mindful of. Another big thing that, you know, I deal with specifically a lot with our spatial tools is we work with a lot of private landowners that are private about their property, and they don't want, you know, necessarily people knowing where they live or where their property is, or even that they have a conservation easement on it. These are very, you know, these are very personal decisions that people are making for their property, for their future, for their children, for their estate. So for us, you know, we have to be very mindful of how we're representing data. I know I showed some outlines of properties on the screen, but being really mindful of, you know, what information that is being shared within those maps when we're in public spaces like this or on our website. You know, we like to boast about our properties, but having to be, you know, a little bit more mindful about where those properties might be located. And so, you know, we're not releasing that sensitive private information of our landowners.
Yeah, so when I think about ethics and equity, I think about ensuring that like the data that you're using, that you're addressing any biases in it. So a great example of this, it's very hard to get pedestrian and bicycle volume data. Not a lot of cities track that. So we can rely on different companies like Strava. They collect a lot of data and give that over to cities free of charge. But when you're using something like that, you have to ask yourself, okay, who is the typical Strava user? Is there bias in this data? Like we talked about, this GIS data is a table with one column of geography. And so understanding the data that you're using beyond its spatial component, understanding what biases it might introduce into your analysis is really important, and making sure that you're addressing that from an equity standpoint.
I think that Bryan and I are in a little bit of a different camp than maybe Ellie and Chelsea are. So we kind of think about it a little bit more broad brush in terms of the systems that we're building, right? So case in point, the PERM, the parcel-based ecological restoration model, is a score of 0 to 100. Yes, you can figure out what goes into that score, but you're ultimately, if you're a user of it, you're trusting that somebody has done the research to actually give you something that you're looking for in that, wrapped into that score. So I think that transparency is huge for Bryan and myself in terms of this is how we put this together, And this, and again, introducing biases, yes. Like, I heard at one point that like, oh, this scored a 100. That's an amazing result for a parcel, but what's more important to that particular is what's wrapped into that score. So this has, 1,000 feet of headwater streams in it that are treating agriculture runoff and things like that. So transparency is huge, or letting people know maybe where something might fall short, what its use cases are, and admittedly also admitting where it could fall short and where you can go with it in the future too. So we're limited here today because of this, and this is where we can be based on the emerging technology or whatever. I think that's all very important.
Okay, one last cross-cutting question, then I'm going to open it up to the audience to see if audience members have questions. This has to do with collaboration. So as environmental professionals, we often work across, multiple domains, environmental, social, infrastructure. How do you approach interdisciplinary collaboration with GIS projects? I mean, what do you think is the biggest benefit from using GIS, and what is the biggest challenge in fostering collaborations across these domains?
I guess I'll go because I have the mic.
Sure.
I think maps are incredibly powerful tools for collaboration. I think we are surrounded by maps every day. We have an inherent ability to read maps, especially when they're made well, when they're made clear, and when they're made concise. So I think it just in the visualizations that we do, it really encourages collaboration. I do a lot of very complex modeling in data science, and being able to explain that to a city engineer, or being able to explain that to a mayor or a city councilor is incredibly important. And so having these visualization tools in GIS is incredibly helpful for that.
Yeah, I think without collaboration and partnerships, conservation wouldn't really happen. And so the geospatial tools kind of work as, that intermediary, that communicator that we so desperately need between organizations, between us and private landowners or residents or neighbors even, to some of our preserves. We can use geospatial tools and mapping to help communicate needs or boundaries or whatever it might be. And maps, while there might be some, there are some accessibility issues, is often, kind of a universal language that most people can understand. And then collaboration, of course, without Aaron and GEOACE, we wouldn't have this restoration model to utilize to elevate our conservation projects. And that partnership to both create the model, maintain it, answer all of our silly questions that we email him on a monthly basis is essential for the work that we're doing right now, and will continue to to elevate the work that we're doing across the region. Our resources are limited, and so you being able to use these tools together as partners in environmental work is essential for the work.
I think internally at our organization, just purely from the software standpoint, as the increased capabilities of sharing between softwares has been really helpful. I mentioned being able to reference in CAD drawings now is great. You can also reference with Adobe products. So if I want to make a drawing of a spillway, I can go into Adobe InDesign and make that a nice beautiful figure, and I can bring that into my GIS map. So just purely from that standpoint, my coworker who's a professional engineer has no GIS experience, but he can create something, and then I can see it and continue the process. And then, we work with landowners like Ellie, and we work with regulators, so state and federal agencies, and it is really powerful to be able to share information. So you don't have to be a GIS expert. I can make my shapefile into a KMZ and send it to you, and you can open it in Google Earth, and anyone can do that. And I just had a landowner that we're doing did a project, and he has an easement on his property, and just asked for that last week. Hey, can you send me the easement boundaries? Well, I'm not going to send him the actual shapefile, but I can easily convert it, and he can open it up on his computer and see right where it is on his property. And same thing with regulators. You know, I can share shapefiles to them, and they can open it on their phone when we're in the field and say, oh, here's the wetland boundary that I'm verifying the delineation, you know, for your permit. And then, you know, with partners, like, anyway, lots of different ways that you can share information, like with actual data and with maps. And then the other thing is really cool, like interactive maps that you can make, so anybody can use those, and you don't have to be like, you don't have to have an Esri license, right? So I made an interactive map for our website, which shows our projects, and you can get on there and you can toggle on and off the layers, and you can get an idea of like what we're doing. So that's very usable. Story maps are very powerful. I know like the Darby Accord, they're kind of reviewing that, and they have a really nice website that's all story maps that shows like, here's the old Accord, here's what we're reviewing, and here's the changes, and here's maps, and here's videos, and it's like a very nice, easily digestible format. And so there's a lot of power in just sharing information.
Okay, great.
I'll be quick.
Sorry.
To tag onto that, sorry. I think 2007 changed the game for GIS. That was ArcGIS Online release. So online maps, I don't think we've kind of talked about them enough up to this point, but they are the collaboration tool that is, it's not even future, that's today. And I think that really from the standpoint of being able to call somebody up on the phone and say, hey, are you seeing what I'm seeing here? And be able to look at the same thing. And you don't have to be a desktop GIS user. That is huge. You get a lot of the access, especially in ArcGIS Online, also with other open source tools, you get a lot of the, what I consider the core functionality to gain insights on the information without actually having to know what buttons to press and things like that, because somebody who does know how to press buttons on the software has done it for you already, or the software is intuitive enough to the human experience that you automatically kind of know how to interact with it.
Okay, great. We have one or two questions from the audience. Harrison's here with a floating microphone. He'll come over to you.
Hello. My name's Roger. I'm a student here at Ohio State, a freshman at Newark currently. I was wondering about, I was curious about how do you think artificial intelligence is going to come into play for the next generation of GIS professionals? Aaron, you mentioned that you had used GIS. You had used artificial intelligence to work out like outlines for farms. How do you think artificial intelligence is going to change like the necessary skill set for the next generation of professionals?
I want to know too. Tell me.
Oh man. So we're using it. And there's a lot of different ways that you can use AI, and AI is big, right? So the biggest topic right now is these large language models. I mentioned it earlier. They can really help you to learn software. They can really help you to even start coding or automating processes and things like that. At the base level, that's changing the game as an education tool, you know, and it will tell you the wrong answer sometimes too, for the record. But it'll at least get you there 90% of the time at this point, because there's good documentation out there for those software. But how I see it changing the landscape, really, I think that the maps get more intuitive. So our job gets more complicated because we have to basically take all of the information, we have to plug it into these models, and then users can just, I imagine a world where people are going to the map and they're asking it a broad brush question about the data and the initiative. And so it's going to be our job to basically stand up those maps and make sure that the data that is returned is accurate. So it's kind of like the hallucination capable LLM meets this concrete data. We need to make sure that we're actually serving the right information out there. You know, the future is here with the machine learning. I mean, that is an expectation when you're working with big data that you are going to use, even if it's just the deep learning package in ArcGIS, you're going to be using machine learning at some point because there's just not enough human manpower out there. So the skill sets that I would encourage people to at least look into and be familiar with are these kind of AI-based, machine learning-based offerings that you have access to now, because that's going to really help you get positions where, if you're looking at GIS as a career, it's going to help you get positions where it's going to position you well for large, answering large problems. And I'll stop there.
I'll echo what I said previously when I was speaking, that you know, GIS is a toolbox. I think AI and large language models are also a toolbox. It's about applying them to whatever you're passionate about, what you have a basis and understanding of. Because of the hallucination, if you can't catch it when it's hallucinating, you can cause a little bit of trouble. But for things like learning Python, which is a very powerful GIS tool, I think it can really be a game changer and elevate your career.
Just super quick, but I think I'll echo that it's a tool. I don't think it's replacing human beings, but I think it could potentially make some of our jobs easier. I'm thinking of like vegetation monitoring. You know, if you have a model that can learn to recognize a plant, hey, that makes it easier for me when I'm looking at this aerial photo of like, what's that down there? You know, some of these kind of things, like I can see that being exciting and being useful. I don't think it's gonna like solve all our problems. And again, it's like garbage in, garbage out. We have to make sure that like data is actually real. We can't just rely on it. Just, oh, it's here. This must mean it's true. So we got to be a little careful.
Time for one more, or we're done.
One more quick question.
So, sorry, my name is Heather. I work for Ohio EPA, and kudos to what you guys do. It's amazing. Speaking not as a GIS person, but somebody who can sometimes rely on what you guys create, I have a really specific question. There was I thought it was a fairly lovely tool. It was EJ Screen that US EPA had. Do you know anything like it that might be available that's very similar to it?
I forget if they took down the social vulnerability index. That can be really helpful, or like, honestly at this point, because so many of those data sets have been taken down, just going to the census and like knowing what data goes into them important, and so you can still pull that and try to recreate it. And hopefully at some point it is accessible again.
Okay, I think we're out of time, so I'll turn it over to Tim Haab, the Director of the School of Environment and Natural Resources, to wrap us up.
Join me in thanking the speakers again. Appreciate all of you taking your time to be here today. Especially want to thank Julia. It's always great to see students coming up here, and it's always impressive to see what students are doing these days, and really can start to make you feel a little bit old when you realize how far behind you are in some of these things. So Julia, thanks for. Thanks to all our speakers too. I really appreciate you being willing to come out and help us with this. Per our EPN tradition, we're going to recognize each of you with a certificate. Harrison's going to hand those out. While he's doing that, I just want to kind of mention real quick, this is just really, really interesting to me. I've been able to see the evolution of GIS over my career. I used it early on and have used it at various times along the way. But when I came into the School of Environment and Natural Resources about a little bit over a year ago, one of the questions I kept asking myself, and I'm still asking myself today, is what is the school? What is a School of Environment and Natural Resources? And as I see the presentations here today, when I think about the school, what we have is we have 5 different majors: environmental science, natural resource management, environment, economy, development, sustainability, forestry, fisheries, and wildlife, and I missed one. Natural resource management. Still, the acronyms go around in my head and I can't remember what all of them are. But the one thing that ties them all together are a set of skills that cross-cut all of those things. And GIS is one of those, and it's so important to us that it's one of our core classes. We're in the process of revising all 5 of our majors, the curriculum for all 5 of our majors. But one of the things that's been non-negotiable in that is the GIS course is going to stay in the core. It's going to be one of those core skills that we think everybody needs as we go through this, along with a social science class, a natural science class, a statistics class, and that's something that I'd really be interested in talking to some of you about how statistics plays into all of this. But it's all of those cross-cutting things that really tie these things together. And when you look at all of these examples that our speakers were talking about, it's not just GIS. It's not just saying here's a map. It's what questions can you answer with that? What are the tools you need? And who do you need to talk to about that? And to me, that's really what the school is trying to do, is trying to figure out how do we get all of these people talking to each other so that we can solve some of these issues. Okay? So just wanted to take a minute to take my privilege as having the pulpit right now. Just a couple of quick announcements about the future of EPN and things that we have coming up. December 10th, we have our Signature Winter program right here in the 4-H Center. We're going to be exploring how local leaders are transforming landscapes and policies to support pollinators and biodiversity across central Ohio. From city council initiatives to grassroots education and ecological design, this event's going to showcase how collaboration is really driving change. Enjoy food, drink, and networking with Ohio State students presenting capstone projects. Then hear from a dynamic panel of changemakers reimagining our shared spaces for a healthier, more connected future. Registration's open now. You can register by following the details on the screen. Sorry. In addition, after the new year, we'll be continuing our monthly programming. January 13th, Old Growth Forests in Ohio. We invite you to join for the breakfast program, Old Growth Forests in Ohio, Lessons for Forest Stewardship in a Changing Environment. We'll explore the ecological importance of forests and practical approaches to their care in changing climate. Then on February 10th, we're going to be looking at the Big Darby Accord 20 years later. This event revisits one of Ohio's most significant collaborative efforts to protect Big Darby Creek while guiding responsible development. You'll hear from experts and original Accord contributors about lessons learned, current challenges, and what's next as we prepare for the 2025 amendment. And finally, before I go, I want to put out a challenge to everybody. Take out your phones. I'll wait. Take out your phones. Laying on your table is a card with a QR code. Scan the QR code, follow the directions, and now you're an EPN member. Okay? That connects you to our network and gives you all the privileges that come along with being a member of the EPN. It'll also, if you're a new member, if you come back to our December event, maybe our January event, you'll get to see your name up here. That's always exciting. Okay. So go ahead and create your own EPN account. It's going to get you access to a helpful director, or access to all of those privileges. And also we have a really exciting announcement coming up. This is just a teaser for this, but EPN has just kicked off development for an EPN Connect. It's a helpful directory of environmental professionals from across Ohio. Imagine having the ability to identify and connect an environmental professional in Ohio based on their expertise, location, or a number of other factors. That's what this website will allow you to do. So if you create your EPN account now, you'll get updates on the new tool when it's launched in early 2026. Finally, go ahead and connect to the EPN LinkedIn page if you have the opportunity. You can do that through the QR code. That gives you to the LinkedIn connections. And finally, one last thing. I think everybody's been excited to see the new EPN mugs that we're using here today. As much as we'd like you to have a souvenir, they're not souvenirs. So what we ask you to do with the mugs is go ahead and leave those on your table. We'll come around and collect those. We were going to have you throw them in the bin over here, but we don't want to break any of them, so because they're kind of expensive and we don't want to have to buy more of them. But go ahead and leave those mugs on the table. We'll take care of those. All of the other scarlet-colored things, plates, cups, other things, go ahead and put those in the bins. That helps contribute to our zero waste initiative here through EPN. Okay. Thank you all again for coming. We appreciate it. Students, always great to see you. Feel free to reach out anytime. And thank you all. Have a good day.